Okay, so example 2. I have an example. So example 1, still under that theorem. Example 1. Find the value of the marked angle. Find the value of the marked angle in the diagram below. The diagram below. All right. So you have, let's say you have a diagram of this nature. Sorry. Yeah. You have here X and you have here 80 degrees. So you have to find the value of what? The marked angle. Okay? Now let's solve this, shall we? So solution. So we say this angle, as you're seeing here, you can see this is a straight line. I get what I'm saying. So the angle are on a straight line. If you draw this angle complete, you're going to have a semicircle. I get what I'm saying. This is a full cycle. I get what I'm saying. When you now cut it into two, you have here 180. Here 180. I get what I'm saying. Good. So this angle on a straight line. So it's simply you're going to apply the first theorem, which is angle on a straight line. Okay? So we say sum of angle on a straight line, which is x degree plus 80 degree is equal to 180 degrees. Open bracket. Sum of angles on a straight line. You must write this narration. What we did here will not make any sense without this narration. The narration is what tells us what you did, the theorem you are employing to do this. So this is obeying a particular theorem. If you fail to write this, you are not telling all the theorem you are using. I know that I'm saying. So you won't get it. Now let's carry on. So x degree will be equal to 180. This having plus, when it crosses, it becomes minus 80. So x is equal to what? 100 degrees. That is it. That is it. So it's that simple. So do well to take a note. Take the note. So, all right. Theorem 2. Let me take this off. Yeah, I've written it. Let me take it off. So, theorem 2. In theorem 2 states that sum of angles, I'm just numbering them so you can remember, okay? I'm numbering them so that you like, okay, theorem 1, angle of the straight line. Sometimes to come, this is my own numbering, okay? Sometimes some angle of the straight line will be your theorem 3, some textbooks. So this is my numbering to make it easy for you to remember, okay? So sum of angles at a point equal to 360 degrees. The sum of angle at a point is 360 degrees. So you have a complete circle. A complete circle, the distance on a circle or the circumference of a circle is given at 360 degrees. And that's how come you are looking for the length of an arc. You're going to have it theta over 360, right? That's the reason. Because of the entire circle is an angle at the point, so it's 360 degrees. So sum of angle at a point is 360 degrees. Your wall clock is 360 degrees. Okay? The wall clock is divided into 4 quarters. So this is how the wall clock is. We have 12, we have 6, we have 9, we have 3, and we have 9. Can you see that? 4 quarters. So from here is half. This is 90, 90, 90, 90. 90 times 4 give you what? 360. Is that also? So that is how come we have this. So sum of angle at a point is equal to 360 degrees. So let me show you. We have something like this. Yes, something of this nature. Or yes, something of this nature. Let me do something else. So we have something like this. Okay, so we have here, and here. Here X, A, Y, and B. So angle X degree plus A degree plus Y degree plus B degree is equal to 360 degree. So take it down, please. Do want to take it down quickly? Not possible. Okay, so I'll take this down so we can take an example. So you do have to pause the video and take it down. All right, so here on that theorem 2, so we have example. Find the value of the marked angle. So we have a figure like this. We have here 60. We have here 108. We have here 30. And we have here X. So find the value of the marked angle. Right. Oh, okay. Let's do something. Let me bring, okay, don't worry. Let me not complicate things yet. All right, so there's a question. Find the value of the marked angle. Like I told you, the marked angle is the angle that has a letter that you don't know. Okay? So we are going to say solution. The solution is this. Angle X degree plus 60 degree plus 108 degree plus 30 degrees is equal to 360 degrees. Why? Sum of angles, this is angles, this is how to write it, sum of angles at a point. Okay, so please add for us, do the addition. 60 plus 108 plus 30, what's the answer? X plus, what's the answer?
$360 minus 198.
So 198 is equal to 360 degrees. So X is equal to 360 minus 198. What's the answer?
162 degrees.
Okay, so 162 degrees. That's the value of X in this question. So you can see that basically simple arithmetic that you're doing. The plus and minus. But this is where the whole point is. And it was this narration that makes people run from geometry. And it's actually very simple. One funny thing is that you cannot escape it in the exam. It's always there. So this is it. Take it down. Okay, so theorem 3. Let me take this off. Okay. Theorem 3. Theorem 3, we are going to consider parallel lines. Please listen before we derive theorem 3. So parallel lines are lines that when drawn, there are two lines or two or more lines that no matter how far you draw them, as long as you follow the straight line, they will never meet. They are called parallel lines. Okay? So you can say this is angle AB, A to B, and C to D. So this is written as AB is parallel to CD. So angle line AB and line CD are parallel. It means they will never meet each other. No matter how far how long you want to draw them, they will never meet. Okay, so we are going to derive theorem 3. But when a line, this line is called a transversal. A transversal. The transversal. So transversal is a line once the mother cuts the two parallel lines. This is what happens. So they're going to produce something. So we have this, and we have this. So this is A, and this is also A. You following? Okay. So when this happens, we say these are called alternate angles. Alternate angles. So when a transversal, okay, so alternate angles are what? Alternate angles are equal. So for this one, angle A, so let me name this theta, okay? So angle A degree is equal to angle theta degree. Why? They're alternate angles, opposite direction. Okay, that's what I'm saying. Alternate angles. So that is it. So our first theorem 3 is that alternate angles are what? Equal. So write it down. Theorem 3, alternate angles are equal. Alternate angles are equal. Write it down. Then I will take this alternate angle off. Then I also take this one off. Take this one off as well. See, using the same parallel lines are transversal. So if I make here A and I call here alpha, sorry, let me use alpha. Let me use here B, for example. This now that's theorem 3. Theorem 4, please. Well, they are theorem 3. Alternate angles are equal to theorem 3. Theorem 4. Theorem 4 now. Theorem 4 is corresponding angles are equal. Corresponding angles are equal. Please take it down. That's theorem 4. I'm going to answer theorem 3 and theorem 4 at the same time. So that's why I'm giving you this now. Alternate angles are equal. Corresponding angles are equal. So angle A degree is equal to angle B degree. Corresponding angles are equal. Have you taken that? Have you taken that? Right. Next, theorem 5. I'll take this off again. Theorem 5. Okay. I'll take this off as well. So ensure that you're drawing the same thing for all the theories. Okay. Theorem 3, you draw it the way I did it. In case you did not do it, this is theorem 3. A and theta. Please draw it for theorem 3. Theorem 4, you draw another one again. This is A and this is B for theorem 4. Now theorem 5. Do where to draw it. Theorem 5 is vertically opposite angles, take it down, are equal. That's theorem 5. Vertical opposite angles are equal. So this is A and here too is A. This here is B. I will name this C. I will name this D. Look at this. Vertical opposite angle. So angle A degree is equal to angle B degree. Also, angle C degree is equal to angle D degree. Vertical opposite angle are equal. So take it down. That is for theorem 5. Vertical opposite angle are equal. Take it down. Have you? Okay. So this is theorem 6. Theorem 6 said that complementary angles are equal. That's theorem 6. Please ensure you write it down. You draw it down. Complementary angles are equal. So angle X, sorry. Sorry about that. Sorry. Sum of complementary angles equals to 90 degrees. We said that earlier. So a complementary angle equal to 90 degrees. So angle X degree plus angle y degree is equal to 90 degree. Sum of complementary angles. Take it down. Take it down, take it down, take it down, take it down. No time. Then we also have theorem 7. Theorem 7. Theorem 7. So we have something of this nature, right? So, theorem 7, sum of supplementary angles equal to 180 degree. Sum of supplementary angle equal to 180 degree. So, complementary angle, the sum of complementary angle equal to 90. Sum of supplementary angle equal to 180 degree. Take it down. Are you taking it down? The other one. Theorem 7. So these are the first basic theorems. The basic of them. These are the theorems. So you must please ensure that you go back and study them. Because after you are going to move into triangles, then into polygons. I get what I'm saying? Then to circles. So the basics, this one that will teach you in even the JSS1 junior secondary school, you will learn this basic of geometry. Okay? This is the very basic of it. So please ensure you go back and I'm just naming the theorems. I'm numbering them for you so that it will make it easy for you to get to explain and understand. So take it down. So we are going to go into solving some complicated questions that are very not complicated, are easy, but it can be solved. All right. Are you taking it down? Okay, so let's move on. Okay, let's take an example. Okay, now we have example. Find the values of the marked angle. Please write in the figures below. A, we have this figure. X, we have A. Next, B, we have beta X 125. We have beta. We're going to find those values that we are not seeing. You don't know them, they are marked. Okay. And C, we have 16 degree. We have D degree. And everything here is X. Yeah. Sorry about that. I think we'll take this in a different sheet because we don't have enough space to write it there. I want it to be. So let me just take this off and bring something else and accommodate it there. Okay. We have X, 3x, and x degree. We have Q, P, A, B, R. Okay, so take it down. All right, so let's answer the questions now. So A, I'll go to my book to get the right yes. So we have a figure that looks like this. I'll just take it. I'll take the figure again so that we're going to see what they are doing. So we have Y, and here is 115 degree, and here is X, and this side is A, right? Okay. Now watch this. To solve this, listen attentively. Listen, look at me, look at it here. Don't write yet. Listen attentively. We are going to consider, first of all, look for the area, the point that has a number. From that number, you can use to find. You know what I'm saying? So let's consider this line. Let's cut this one out, something like this. And this now, let's cut this side. And here we have Y, and here we have 115. I see that. I see what I've done. Or you can cut this side. You can say this side. You have 115, and you have X. Any of them you want to cut, it's still gonna get the same answer. Because it is the one that have a number. From here you can begin to solve and find the rest. Okay? Let's carry on. So either we want to do it. Which one? Okay, let's use this down one. So let's cut this one off. Now let's find X in relationship with this one. So X, this angle on the what? On the what?
Parallel line.
No. This one is a what? Okay, let me write it in that way so you understand. You will remember. What is that?
An arc.
Not an arc. Wait, I will mention arc here. This is a straight line. Are you not seeing it? It's a parallel line. It's a straight line. I know what I'm saying. So this angle are on a straight line, right? So what is the theorem that has to do with straight line?
Any straight line is
now let's revise the theorem. Which theorem has anything to do with straight line? I'll give you all the theorems. Which theorem has to do with straight line? Think very well. Is there? Open it. Which theorem has to do with straight line? Which of the theorem has to do with straight line?
is between 3 and from 3 to 5 or 3 to 7.
Open that. Bring your first page. No. This one. Open it. I'll give you that. I'll give you that. Which angle has to do with straight line? I know the theorem.
Angles of a straight line.
I don't see it there.
Yeah.
So angle on a straight line is equal to what?
180.
Good. So I'm using a straight line angle. So look at this now. So it's going to be x degree plus 115 degree equal to 180 degree. Why? sum of angles on a straight line. Are you there? So x degree is equal to 180 minus 115. What's the answer?
Is equals to 65 degrees.
65 degrees. So 5 degrees. That's the value of x in this question. 65 degrees. I've gotten x. I've not found everything. So that's for x I've gotten. Now, so we now know that x here. We now know that x is equal to 65 degrees. Okay? Now what of y? What of y? Now, there are two ways to get y. You can choose to follow the same thing, y plus 1, but I don't know what I said. Remember, there's a theorem we say that vertically opposite angles are what? Are what? Okay.
Vertically opposite
Angles are what? Are equal. Look at this. This one and this one are on the same vertical plane, but they're opposite. I get what I'm saying? So, angle y is equal to angle x is equal to 65 degrees. Why? Vertically opposite angles. That's why. It's the same thing. Good. Take it down. Before we look for angle A. Meanwhile, watch this. If angle, look at this. Angle Y and angle A are what? Corresponding angle. They are in the same direction. So, corresponding angle are what? Corresponding angle are what? Check your theorem.
Equal.
Good, are equal. So the reason is because they are corresponding angles. And you're done. You've completed. Answer the question. So angle y is equal to 65. E is equal to 65. And you're done. Take it down. You're going to write this side first before you go to this side, okay? So look at the second one. We have completed it. So the second one looks like this. We have a line, another line that came like this, and we have another one that runs like this. Or this one not there. We have theta. We have x. We have 1, 2, 5. We have beta. Yeah. So to solve this, I want you to see something. Like now, look at this. Are you seeing this? So let's extend this now. To be like a transversal. So these are three parallel lines, right? These transversal are cut through. Then also, now look at this. So you can say, can you see this guy? And this guy, right? They are in opposite directions. That also. So opposite direction angles, I gave you that angle on the opposite direction, not the same direction, opposite direction, are referred to as alternate angles. Alternate angles are angles of opposite direction. Is that also? So we say angle x is equal to 125 degree. Why? Alternate angles. And they are equal. So x is equal to 125 degree. Now you're getting x. Let's find theta. So we have something like this now, cut. So you have here theta, and you have here 125. Right? So remember, this line, this is what? A straight line, so straight line. So a straight line is what? The theorem.
Straight line.
Theorem, that's theorem 1. Some angle on a straight line is equal to what? 180 degree, right? Please follow. Some angle on a straight line is equal to 180 degrees. So angle theta plus, that is to find theta. First of all, was to find x, I've gotten x. So to find theta, we say theta plus 125 we go to 180 degrees. Why? Sum of angles on a straight line. Right? Good. So you have this. So we say theta is equal to 180 minus 125. What's the answer? 180 minus 125. 55 degrees. So you have 55 degrees. That's your answer for theta. So you are gotten theta. Theta is equal to 55 degrees. Equal to 55 degrees. Now, let's get beta. Take it down. Take it down quickly. Take it down quickly. You can decide to draw, or you can decide to draw. Question already in your book. But you must write all this. You must draw this one that I cut out. You must draw, show that one. But the other one you can leave it. So that is that. Please take it down. So that's what we have. Now let's find beta, shall we? So to find, this is beta, the Greek alphabet, okay? To find beta, as that is written, the long tail B. To find beta, look at this. To find beta, so if here is 55, here 55, and this one is also in opposite direction with this one, is it not so? Opposite direction, is that not so? Opposite direction. So angle theta, beta is equal to theta is equal to 55 degrees. Why? Still alternate angles. Alternate angles. Alternate angles. Simply angles on an opposite direction are referred to as alternate angles. So this one, first of all, we started with this guy, is opposite of this one. This direction. Alternate angles. Now we use, till we got this guy, we didn't know this one. We use some angle on a straight line to find theta. Now theta is on opposite direction with beta. So it is an angle on opposite direction are referred to as alternate angles. And alternate angles are what? Equal. Is that not so? So that's why we have that. So please ensure you take it down. Pause the video and take it down. And if you have any question, please just drop it in the comment section. I will attend to it. Thank you. Let me go off with this. Right. Final one. Yeah, something like this. This is the final question I'm going to do before we go off for tonight. Sorry about that. Something like this. Yeah, this, and this. And this is 2x, right? This is 3x, and this is x. So we have to find the value of x in this equation. This is very simple. This is very simple. We have something like this. Anywhere is equal to 90 degrees. You get what I'm saying? That's a 90 degree. And that's how come when you have this kind of triangle, it's called a right angle triangle. 90 degree. So this is 90 degree. So it simply means that this is complementary angle. So it's going to be solution going to be 2x plus 3x plus x equal to 90 degrees. This is 90 degrees totally. Why? This is what? Complementary, sum of complementary angle. Sum of complementary angle. Complementary angle. So let's add 2x plus 3x is what?
5x
Plus x.
6x.
So 6x is equal to 90 degrees. So find 6x alone. Divided by 6. Divided by 6. X is equal to what?
15.
15 degree. That's it. That's simple. Geometry is sweet. It's simple. So when next we come, we're going to consider other examples, and probably, we're going to enter into triangles. I'm going to consider how triangles are. I will give a little teaser of it. So in triangles, we have three, it's shared with three sides, and we have different kind of triangles. We have the scalene triangle that has no side equal. We have the isosceles triangle, opposite side equal, and the opposite angle are equal. For that of scalene, no side equal, no angle equal. Are you getting me? In isosceles, two side equal, two angle equal. In scalene, in a quadrilateral triangle, all sides are equal, all angles are equal. And finally, in right angle triangle, one of the angle is equal to 90 degrees, that we say here. So we're going to be looking into that. We're going to look at some of angles in the triangle. The sum of angle in the triangle is equal to 180 degrees. We're looking at the opposite, the interior and exterior angles of a triangle, and many more. You're going to really enjoy the geometry. Just sit tight, keep studying, ask questions when you don't understand, and we'll be here to make mathematics as simple as possible. So stay well, remember blessed. Bye for now.